So I'm Praveen from the Galaxy Technologies. So I'm the trainer who's going to take classes for Docker and Kubernetes course. So
Okay,
today
thank
it
you.
will be introduction class for the Docker and Kubernetes. So what I'm going to teach inside this Docker and Kubernetes, like a demo for Docker and Kubernetes. Okay. So actually today I was just waiting. Few more people need to join, so that's the reason I was waiting for them. So okay, let's start now. It's already 15 minutes late. So before that, let me introduce myself. Myself, Praveen Kumar. I have total 11 years of experience in IT. So I started my career as an AX administrator. It's one of the Unix flavor. Then I switched my domain from AX to the Linux administration, and I worked on Linux administration for a couple of years, and then I moved to AWS cloud. So I have very good experience on the AWS cloud and Azure cloud, and very good exposure on the DevOps. So from last 3 years onwards, I started working on DevOps because I got opportunity in my organization to work on the DevOps. And in DevOps, especially, I have very good experience in Kubernetes because from last 1 year onwards, I started working on Kubernetes, especially containerization. So I was a single person in that project who handled end to end, like from containerizing to deployment and managing the Kubernetes cluster, building the Kubernetes cluster, like creating Docker files for applications, Java microservices, and writing the Jenkins files, creating the Helm charts, and deploying that applications into the Kubernetes cluster and managing the Kubernetes cluster, and especially into the Azure Kubernetes service as an Kubernetes service. So very good experience on the AK side. Okay, overall. So this is about my professional experience. Coming to the teaching experience, initially I used to teach Linux administration course with real-time scenarios to get the job for the students. And afterwards, I switched from Linux administration to the AWS training. And still I'm taking AWS sessions and then DevOps sessions also. So this is the second batch we are taking as on the Kubernetes course. Okay, so this is about my teaching experience. Now, before we are going into the Kubernetes, first of all, why we need Kubernetes? Can anyone tell me what is Kubernetes? Anyone have idea?
Kubernetes is a container orchestration tool that is used to automate.
Okay, so what do you mean by orchestration? Guys, those who don't want to
Club
speak, please go on mute.
cluster.
So what do you mean by containerization? Containers. See here, previously, I hope like most of you guys know, like you are from the infrastructure background, or maybe from the testing background, or maybe some of you are from programming background, right? So most of you know, like we were dealing with the physical servers, right? So if any application want to deploy, previously in 1990 to 2000, 2005, we were dealing with the physical servers, installing an application inside a box, physical box. On top of that, there will be operating system will be there, and on top of that, we'll install, deploy the applications to run any application. And then virtualization came into the picture. Then we'll install one hypervisor on top of one physical box, and then we can create multiple virtual machines. That is a virtualization revolution came into the picture. And after that, now in the current scenario, we are using Dockerization. Every applications are installing inside the Docker. Most of the companies are preferring and migrating from virtualization to the Dockerization. So what is Dockerization? That we'll start discussing from tomorrow onwards. What is Docker? Why we need it? So I think those already completed DevOps, or maybe most of you guys might know what is Dockerization. So containerizing the applications. So why we containerize, what is containerization, that will start discussing from the Docker sessions onwards. So nowadays, every organization, their applications are converting it as an Dockerization, which means containerization. So containers will be created. So in the real world, in the enterprise world, lot of servers will be there. Okay, maybe lot of machines will be there inside that. Lot of Docker software will be installed. On top of that, multiple containers will be running. So like that, lot of machines will be there. So individually, each machine is going to run with the Docker, but how it is going to manage? Okay, so we will call as an orchestration. So orchestration means what? Basically, you might be heard musical orchestra. So what is musical orchestra? What is musical orchestra? So one person will be guiding everyone, instructing a bunch of people with set of rules, set of like rules, so that they are going to follow him, right? So let me show you the picture. So if you see here, one person is going to stand with the stake and he's going to instruct the bunch of people. Based upon his instruction, the best music is going to come, right? So everyone is going to listen this person. So he's called as an orchestrator. Okay. The same way here, you have bunch of Docker machines which are running with the Docker. So who is going to manage it? Like auto scaling of a container. If it due to heavy load, the container should be auto scaled, or the container is died, then new container should be created. Load balancing. So lot of things will be there. So who is going to manage from the back end? So that is called orchestration tool. So there comes the Kubernetes. So Kubernetes is an orchestration tool which manages all your Docker containers, Docker nodes. Okay, so Kubernetes is not only the orchestration tool. We have few more orchestration tools are also available. Like lot of orchestration tools are available. Like Kubernetes is one of them, and we have a Docker Swarm, and we have Cloud Foundry and Mesos. These are the like enterprise orchestration tools. Most of the companies might using Mesos, which is from the Apache, and Cloud Foundry or Docker Swarm and Kubernetes. So apart from this, there are some other tools also available. Those tools will not be using in the enterprise level. So some small tools might be there. So these are like famous 4 tools which will be using in the organizations, enterprise organizations. Okay. So here, among all this, why everyone, like most of the ratio is using by the Kubernetes. So why? Because the first reason, it's an open source. Okay, it's an open source and it's created by the Google, and Google was using this Kubernetes for their backend containers from 2006 onwards itself. Okay, so you might be heard Google downtime for last year. It's only I think 1%. Okay, so very less downtime Google will provide, because backend they are using this containerization technology with their own software called orchestration tool, this Kubernetes. Okay, and later on they hand over this Kubernetes tool to the CNCF, Cloud Native Computing Foundation. So they hand over to the CNCF organization, because this is an open source. See, in open source also again we'll have multiple things like paying. We need to pay some fee for licensing or maybe for support, but Kubernetes is completely free of cost. We are going to get the software, and we have a very huge community for this Kubernetes also. And that's the reason majority of the companies are using Kubernetes. And compared to Docker Swarm, so Docker Swarm is a product of own Docker. Okay. So, but lot of benefits are available into the Kubernetes compared to the Docker Swarm. Like lot of components, features are available in the Kubernetes, which are not available inside the Docker Swarm. Okay, and Kubernetes is will support 2 types of containerization. One is Docker and another one is Rocket. So these are the 2 container technologies are available in the market. So Kubernetes will support this Docker and Rocket. 90% every organization will use Docker. Maybe few companies might be using Rocket containerization. So Kubernetes will support both. It's an orchestration tool. So front end it can be Docker or it can be Rocket. Okay, and why? Another major reason is scalability. Okay, so here Kubernetes will help us for scale your applications very easily. Okay, So what are the applications we are deploying into the cluster, like into the Kubernetes cluster? So it will run on the Docker containers, but in the Kubernetes terminology, we call it as a pod. So easily we can scale up within very, very less time. We can scale up the applications. Okay. And another important reason is version control. So what is version control?
To track the changes.
Yeah.
With the version number. Yeah.
Like GitHub.
Okay. So what do you do in GitHub? What is the advantage? Why we call it as a version control?
Multiple developers should be able to handle the code, and they can check out, and another person can also work on the same, and they can combine the code. They can manage multiple resources.
Okay.
Maintaining the different versions of any software, that version control can be managed with the help of version control. We can manage them.
Yeah, they can also roll back and go back to the previous version in case of an issue.
Yep. The major is we can roll back, right? Version control means we can maintain multiple versions of that. Like developers will do a lot of changes to the code, and whatever the changes we are doing, so that can be saved as a version. So we can go back to the previous version if you want. The same way here also, like in Kubernetes, if you see version control, so update deployed pods using newer versions of applications, images, and roll back to an earlier deployment if the current version is not stable. So here, whatever the deployment we are doing, okay, we deployed one application, like developers change the code, and that will be available in the source code. And by taking that source code, we created a Docker image, and the Docker image will be deployed onto the cluster. But it is not working as per expectations. Again, we can roll back to the previous version, what it was running before. So that will be immediately it is going to be run. Like for example, in Kubernetes, we have 6 application deployment strategies. So if we go through this website, so we should know like different ways to deploy the applications. Mostly these are the 6 strategies to deploy the application. So recreate, ramp, the blue-green deployment, canary deployment, A/B testing, shadow deployment. So here what it will do, ramped means as a rolling update, or incremental version B is slowly rolled out and replacing version A. We'll discuss most of this ramped or blue, green, or canary in our coming sessions, how we are going to update our applications. So here we see one chart. Okay, this is the one. So here if you see ramped means, if you see here rollback duration, it is taking lot of time. So rollback means you're going into the previous version. If your application were deployed with the ramped means a rolling update option, it will take lot of time, but cloud cost will be less, because means if you are deploying this into the cloud environment, then cloud cost will be very, very less, but it is taking lot of time to roll back. So if it is taking lot of time to roll back, there will be a lot of downtime will be there for your application, right? So if you take the blue green, the very famous we use in the real time for our applications to deploy. So we use blue green deployment, and you see rollback duration, it's not even taking like very, very less time. So there is no, even 1% is also it's not selected, it's less time. But cloud cost is more, little bit more. Why? Because it is going to be create separate set of containers to run, like 2 parallel set of containers are going to be run. So easily you can switch to the older version. So we'll see how we can do this blue green deployment. Okay. So version B is released alongside version A, then the traffic is switched to version B. So it will take very, very minimal time to roll back to the previous version, but cost wise it will be little bit more. But here important is rollback duration. So how quickly we can go back to our previous version which was running early for our applications. So this is how we can do with the Kubernetes. So version control we can do, we can switch back to the previous versions. Okay. So that is another good advantage. And I was talking about scalability. Software can be deployed for the first time in a scale out manner across pods, and deployments can be scaled in or out at any time. So we are going to see how we can scale out and scale in our applications very in a quickly manner and easy and fast. How we can scale out and scale in our applications like containers, how we can do that. So that is another advantage inside this Kubernetes. Okay. So now Um, see, we'll have two types of Kubernetes will be there. One is a manager Kubernetes service, and another one is you are going to manage. Like manually, you are installing the Kubernetes on maybe on VMware virtual machines, or maybe AWS virtual machines, or it may be any cloud, whether Azure or Google Cloud. You are creating virtual machines by using any Terraform script, creating infrastructure, and you can use Terraform script to install Kubernetes. It's like a manual process you are installing in those virtual machines. Means you are managing them because you are installing, downloading the software from the Kubernetes Google page, and you are installing it manually, and you are going to support it. No one is going to help you. But if you don't want that, you can go with the manager service. So what is managed service? So we have AKS in the Azure and EKS in the AWS and GK in the Google Cloud. So they are providing you this service. So they are going to take care if anything happens to the cluster. So we don't need to worry. We can raise a case with the vendor. So they are going to take care of our cluster environment. Okay, managed service. So most of the organizations will use managed service, or some people might use the OpenShift. Like inside the OpenShift, it's nothing like a basically Kubernetes is like a plain version, and Red Hat guys, they took this plain version of Kubernetes and they did some modification to a few objects, and they wrapped up. It's like an OpenShift. Okay, so it can be anything, but mostly it will be in the cloud, like either AKS or maybe GKE or maybe EKS. Okay, or some companies may be using um, manually installing. Okay, again manually installing also there will be two process. Okay, so one is called as an COPS and a Kubedium. Means when you are installing manually, so no one is going to manage, it's managing by you. Then
I have a
the
question. I
installing,
have a question.
yep,
So you will be teaching us Google Kubernetes or AKS, which one?
GK,
GKS, right?
yes.
Okay, great. Thank you.
Okay, so manually we are going to install on COPS and Kubedium. So these are the two methods we'll discuss, like how we can use, and I'll show you any one of the method how to install even in not about the managed service manually. If I want to install, how we can do that. That we can automate by using some Terraform script or any like if you are using Azure, then we can go with ARM templates, or maybe AWS, we can go Cloud Formation. Okay, in real time, that way we'll automate so that we, whenever we want to create a new cluster, we'll create a virtual environment with Terraform script, and we'll use the same Terraform script to install this cluster software. And the same Terraform scripts you can use in the real time to create your managed service also, whether it's an AKS or GKE or EKS. In the real time, we don't go to the console and GUI, and we manually we don't create clusters. We'll use Terraform scripts only, okay, or maybe ARM templates. So this is about manager services. Again, it depends upon the organization, which organization is choosing which like manager service, whether AKS or GK. Again, it depends upon a lot of dependencies, and maybe uh, how their applications are running. If they are running any dependency with the Windows applications or Windows databases should be connected, then they might use AKS. Okay, so it's completely depend upon the applications what they're running. Based on that, they will choose which manager service they want to go, which is very more comfortable for them. So now we'll talk about the resources what we are going to discuss. So compulsory we need to know about first the Docker. So we should know what is Docker and how it came into the picture, and how to create images of the Docker images, and writing the Docker files, and basically Dockers will be for stateless applications. Stateless means it doesn't require any data should be stored. But if any data should be stored, that is called as a stateful application. So for that we need to create volumes. So how to create volumes in the Docker, and how to store these Docker images once we create the Docker images, and where should we store. It's like an artifactory like Nexus or JFrog artifactory. We can store those Docker images. So we'll discuss all these Docker components, because as I said, see, end of the day in Kubernetes also it is going to run on the Docker. It's like it creates a container and it's run as a Docker container. So we should have very good knowledge in the Docker architecture, how it will work, okay, to troubleshoot the Docker, and the logs to see of each container, how it will work. And once we finish with the Docker, then we'll come into the Kubernetes. Okay, so we'll discuss Kubernetes architecture, like what is master server, what are the nodes, and what are the components are running on master, and what are the components will run on the uh, worker nodes, how it will work, how it will communicate, and how we can access cluster through API calls, how we can send API call to the master so that it will respond to us. That will discuss Kubernetes architecture and components. And as I said, Kubernetes can be installed in many ways. Like as I said, this is one of the method, kops and kubedium, which we use in the real-time environment. And like for example, we are developers or maybe we are administrators like DevOps engineers. Then we want to test it locally before I want to deploy it on the real environment. Then I can have a Kubernetes cluster environment even in my local also with the help of Minikube. But in Minikube, you don't have much features. Not all the features you are going to get to test it. So when I was working on the Kubernetes for deploying the applications, containerizing the applications, I created my own environment in the cloud, and there first I'll test it everything, and then I'll same thing I'll implement it on the cluster. I never used Minikube, but I will show you how to create Minikube environment and some basic things how you can test it, because again we need to have separate environment to test it, because everything will be not available inside the Minikube. Limited resources we can able to get. And as I said, another one is one Kubedium, and that is one way to install the Kubernetes cluster on any environment, like whether it can be VMware environment, Hyper-V, virtual mean on-premises data center, or maybe in the cloud you are creating manually virtual machines. On top of that, we can install Kubedium on any of the cloud. And kops is also same, like kops will reduce the workload. Like in Kubedium you need to follow a lot of steps. In kops, previously this kops was supporting for only AWS, but now kops is also support for DigitalOcean, Azure and GK also. In these clouds also, there we can able to install with the kops. Again, this is also, it's like we are managing the cluster. No one is going to manage. Only virtual machines will be managed by the vendors, and we are going to manage the cluster. Apart from this, as just now I said, managed service, AKS, EKS, and GKE. See, everything is same. The Kubernetes cluster concept will be the same. Only thing is, if you are using GK, you are going to raise a case with Google Cloud whenever the issue comes, or maybe AKS. That is the difference. Little bit differences will be there. Apart from that, cluster functionality, cluster features, everything will be same. And given this networking, we should understand how the pod networking will be there, how internal it will communicate each other, different worker nodes will be there. So that networking part will be covered, and the resources of the Kubernetes, like what is namespace, what is the purpose of namespace. In real time, definitely we'll use multiple namespaces to deploy our applications. So what is the purpose of this namespace, and how we will deploy our containers like applications inside the cluster. Multiple ways are there, like replica set, daemon set, stateful set, and deployment. So this is we are going to discuss. And here this pod is nothing but it's a container. Okay, so while we talk about pod, we'll talk more about, it's like a wrapper, wrapping up a container. On top of that is called as a pod. Okay, so to deploy this pod, we'll use either deployment or replica set or daemon set or stateful set. Each one will discuss in detail what is the difference between each one of them, and which one is more suitable to deploy our applications. And when we're deploying these applications as a pod, Then we have many other resources we need to add it in the manifest files like configuration file, like labels and selectors. Like we can provide labels, right? You know what is the purpose of labels? So identify easily. Some like you have hundreds of containers are running. You want to figure it out which are production containers or which are staging environment or which are specific application related. So you can give the labels and you can filter it out. Okay. And selectors means what? So you are selecting one application to go and like for example, you want to configure load balancer. So how come this load balancer knows that this load balancer should be belongs to so and so application? So with the help of selector. So whatever the selector name we are giving in the application configuration, that selector name will give into the load balancer so that it will identify, okay, I'm going to create this load balancer for this set of applications. So that's why we configure selectors. And config maps. Config maps is also very important in configuring the real environment. Like in real time, some applications are dependent to communicate with the database, or maybe some applications are dependent on another part. Like let me show you in the diagram so that easily you can understand. Let's say assume this is our cluster environment and these are like some worker nodes are available, and assume this is the master server. In real time, your database might be inside your Kubernetes cluster also running as a container, or maybe it is running as a separate database, maybe database as a service. Assume if you are taking AWS, maybe it's an RDS service, separate it's running, and this is EKS cluster, assume. So one of the application want to connect to the database. So this application will go and connect to the database. So to connect to the database, this application needs credentials to connect the database and the URL to connect the database. If it's DNS URL is there, the DNS URL should be configured inside this application. When you are deploying the application, so when the application is getting started, so in the process, it should go and connect to the database. So where we are providing those credentials and the URL of the database. So in the config maps, we will provide the credentials and the URL of this database so that it will use at the runtime and it will go and connect the database and it will establish the connection. Okay, so that's the reason. And another reason is maybe you are having multiple applications, like we call it as a multiple, might be microservices. So this container want to connect to this container. There is a dependency to run your application. So how it is going to connect? So in the config maps, we'll define this application name equal to, it's a like key value pair, and we'll give this service name of this container so that it will go and connect to this one. So in the deployment process, it will be hierarchy will be there. Like first it should deploy this one application, because without deploying this application, if you're deploying this application, this is a dependent on this one. If it is not available, then this will not work. Your container will be not in the running state because it is expecting something to communicate with this one. So this URL, okay, service URL, service, we call it a service disk or URL. We don't give IP here because containers will not have a permanent IP. They are not immortal, right? They are mortal. So anytime they can die. So we give service disk or URL. So that URL also will define in the config maps. So that is the reason we use config maps for every application. So not only this one, config maps we also use to change the values, right? For example, in the application, to run the application, as I said, this is one of the example to connect the database or maybe to connect the other microservices or other applications. Apart from this, there will be some configuration will be there for that application, like what is the log file location and what is the timeout, session timeout, timing. All this will be in the properties file. That properties file we are converting into the config maps. So those things we can change in the runtime. That is an advantage of the config maps. And the difference between secrets on config maps is, in the config maps, you can see these credentials as a plain text format. So we should not give credentials or any key values, like instead of username password, sometimes we use keys to connect to the another database or another service. So those should be encoded, not encrypted, encoded inside the secrets. So we use secrets to encode the credentials or any key pairs inside the secrets, or else everything will use in the config maps. So how we can use it, that will be discussed. And jobs, we can schedule the jobs also. It's like a cron jobs, we can schedule the jobs. And init container, what is the purpose of init container? Whenever you want to create a container, application container, before that init container will be created, and it will go and check everything is working fine or not, and then it will allow to uh, deploy the actual container of the application. And how we create, what is the purpose of it, also we'll discuss. And another important is services, network services. Whatever the application we are deploying, so it will communicate internally, but how it can be accessed to the external world, so that we can configure either node port or load balancer or cluster IP. What is the difference between these three? And when we use these services, in which scenario? For database, we use cluster IP. For a web application, we use load balancer. Okay, we don't use much on node port. Mostly we use load balancer or cluster IP. Internally, it will be cluster IP, and externally we use load balancer. And again, here also we have a volumes concept. So persistent volume and persistent volume claim. So when we use storage, as I said, basically this Dockerization will be for stateless application. Means the data is not going to be stored. Whatever the content is getting created, if it is generating any data, if we don't want that, then we call it as a stateless application. But whenever any application, like for example, you're deploying database. So database, obviously we want the data compulsory. So if you want the data, then you should have a volume, because if the content got deleted, the data will be also erased. So what we are going to do, we are going to give like external storage to that container. So even the container got deleted, still the external storage will be available when new container gets created, and it will take this volume. Like in the traditional data center, how storage guys are giving lunch to the physical server. Basically, physical server is also having internal hard disk, but still we are using storage guys will allocate storage to the physical boxes as a logical storage. So we'll create file systems as an administrators, and data is getting stored. Even though server is crashed, completely damaged, still we have volumes data with us. We can attach those volumes to some other machine so that we can access the data. Same way here. So we have a lot of different entities we can create storage. Like if your cluster environment is in the AWS, then we can use EBS block storage. So we can create a storage, and we can create as a physical volume, and that physical volume can be used to any of the pod as an persistent volume claim. If I created 100 GB of physical volume, that 100 GB of physical volume we can give it to any of the pod, okay, as a physical volume claim. It is claiming, and it should have physical volume should be available. If you are using Azure, then Azure disk is there, and in Azure file is there. So multiple storage benefits are there in the Azure. And in Google Cloud, we have GC or GCP persistent disk is also available. So apart from that, you can create iSCSI storages, or like NFS storages also you can allocate. That we'll discuss in the storage part, like how we can allocate storage to the pods if the application or database is storing the data. And like NFS, host path, MTDR, multiple storage volume classes are also available. And deep dive into the Kubernetes security, like we call as an role-based authentication. So we can provide access. Like for example, if we are installing Kubernetes, okay, if someone knows that IP of that master server, they can able to log in as a root if they are logging in. But here I can give access. Like for example, there are 10 namespaces are running. In each namespace, different applications are running. If I'm giving access, if I give you the IP and access to that cluster, then you can able to access the complete cluster and everything. You can delete the parts of every application. You can delete the cluster. You are going to have full access. Instead of that, we can create access to specific resources only, so that we can achieve with the role-based authentication with the Kubernetes security. So how we can create that, how we can create service account, how I can give a user to access specific resources only, that will be configured inside this RBAC. And see, Kubernetes resources, we can learn it anywhere, right? We can learn it in YouTube or Udemy courses, but most of people know what are the components of Kubernetes. But if you get opportunity to work in any organization, like in your organization, suddenly they thought to switch to the virtual machine environment, to the containerization with Kubernetes. So how we are going to start? That is very, very important. So okay, you have learned Kubernetes, what is Kubernetes, what is volume, what is what. But if you get opportunity to convert your application, the for example, if it is Java application and Java guys converted that application into the Spring Boot, because if it want to run as a microservice, then the application level changes also is required. So they converted into the Java Spring Boot. Their work is done. Now it's DevOps engineer turn to write the Docker file for that to containerize, because it was running on the virtual machines. Now that software you want to run it on a container, small container. So for that you need to write a Docker file. How you are going to write? So you are going to work with developers, because what to write a config map file, how come that application is dependent on what things? So whether that application is dependent on connecting database or maybe another pod, so that they will know. So how to work with developers and how to write that application properties. So and how you are passing that properties at the runtime, everything will be decided in the Docker file. So how you are going to create Docker file, and after creating Docker file, what you are going to do, how you need to run it on the Kubernetes cluster. So how you are going to do it? So you need to configure Jenkins pipelines, okay, declarative pipelines, so that first what it will do, it will create an image and it will create an artifactory, and that will be stored on the Nexus or JFrog. And then from there, how we are going to deploy that microservice or application into the Kubernetes cluster through the deployment through the Jenkins, how you will do it. So here comes the Helm charts. So Helm charts are the package manager for Kubernetes. This is specifically for Kubernetes. It's like yum installation in Red Hat and CentOS, and apt-get for Debian and Ubuntu, pip for Python. These are package managers. Same way here Kubernetes, we use Helm package managers. So we have very good understanding about Helm. What is Helm? How we can create repositories of Helm? How we can store Helm charts? How we can create them? What's the directory structure of Helm? So all these things, what are the advantages? Why we should use Helm chart? So by using this Helm chart, we are going to deploy the application onto the Kubernetes cluster by using the Jenkins server. Okay, so here comes the real-time scenarios. So I'll take some open source Java applications or Node.js applications, then we can deploy onto the Kubernetes cluster. So for that, we'll create Helm charts, and I'm going to create Jenkins server, and we are going to do continuous integration of the application. And once the Docker image is created, and the Docker image should be deployed onto the cluster. Okay, so once it is deployed, we can do the testing, like as I said, blue-green deployment, like in real time, how you configure blue-green deployment, like without downtime or with very less downtime, how you can do that. We'll see that. Okay, and how to do the scaling of your application whenever there is a high CPU utilization, how pods will get scaled up and scaled down based upon the CPU utilization or memory utilization. We'll see practically. And another important thing is you'll get request, like for example, application guys want to see the logs, because whenever we are doing, because for the first time whenever you're deploying to the Kubernetes cluster, they want to see the logs. Okay, you cannot give them the root access to the master server, and you will not ask them to go and check the logs. They don't know kubectl Kubernetes, they don't want to see that, so they want to see in the dashboard. So how you can configure that? With the help of EFK, Elasticsearch, Fluentd, and Kibana, how we can configure inside the cluster to get the application logs and to get the Kubernetes logs, so that they can also view inside the dashboard. And that logs you can again configure with any ticketing tool like 24/7 or PagerDuty, so that you can configure those logs means whenever like any, you can mention the keyword whenever the application is down. Okay, so regularly this ticketing tool will go and check and monitor it, and if that specific syntax it founds, then it will immediately raise a ticket, and it will, if you are any on-call person, it should trigger a call. This all the things you can configure with that Kibana. So we are not going to discuss about how to configure that. We will discuss only up to configuring the dashboard and how to see the application logs and Kubernetes logs, and how we can configure filters. Like I want to see specific pod logs, or if you want to see specific namespace containers, how we can see that, we'll configure inside that EFK. And Prometheus and Grafana will see for metrics like CPU resources and metrics, all the things we can monitor inside this Prometheus and Grafana. Okay, and finally we'll discuss about a little bit like what I have faced in the real-time scenarios, little bit of troubleshooting, how we can solve. If you are using managed service, mostly you are not going to solve the issues. You are going to contact the vendor, so they are going to come. But at least before contacting them, you need to go and check what exactly is the issue, where exactly we are facing. Mostly it will be infrastructure related issues only. Okay, so that is how we discuss about the troubleshooting in the final session. Okay, so this is about the curriculum and what we are going to discuss. I think it will take 20 to 25 days of time. In daily it will be 1 hour or 1 hour 10 minutes, depend upon the topic. It may go to sometimes 1 hour 10 minutes or 1 hour 15 minutes or 1 hour. Okay, so Monday to Friday will be there classes. Saturday Sunday there will be no sessions will be there. Okay, so this is about the course. Okay, so if you guys have any doubt, you can shoot.
Do you have any batch in evening?
No, as of now, no.
Okay.
Monday, what is the timing? I mean, daily.
Daily it will be 7 o'clock, 7 a.m.
7 to
IST,
8.
8 a.m. to 8:15 a.m. IST.
No, is it 7 to 8 or 8 to 9?
7 to 8.
Acha, okay. And other thing, so the topics which you are showing here, okay. So
Hmm.
it will be just a fast track program kind of a thing, or you will be, like explaining us in detail, because all these things, I think it can't be covered in 20 days.
See, that is what. In detail, in the sense, everything. See, even if you take only single Docker, can also we can teach for 1 month. So how depth we are going
Correct.
means, so what up to what level we are expecting. Like, so Docker volumes it will be complete in 1 hour. For Docker networking, it will be finished in one hour. So that way, we are going to practice. Okay.
It will be a practice session, right?
Yes, practice session only.
Practical. Okay.
Yep.
And other thing, so I mean, so at the end, okay, so you will be showing us the entire thing, right? Implementing all the
Yes.
services, everything, right?
So
End to end.
whatever you find here, I am going to discuss and show you practical of each and every topic. Okay. See, apart from this, there might be having lot of other components also in the Kubernetes. Okay.
Hmm.
So we are not going to discuss all the components because Kubernetes is having lot of components. So
Hmm.
majorly when we are deploying the applications, these are the components are required. Remaining are optional. So some organization may use it, depend upon their application requirement. Some may not use it. So, but most of these components, these are the important components from the cluster. So whatever is defined here, we are going to discuss and do practical of them.
Hey
Okay.
Praveen, do we get any access to cloud servers?
Now you guys need to create a Google Cloud account, which is free for 1 year. Okay, we can use that 1 year free account and we can do practical inside that Google Cloud.
Oh, in the Google Cloud, not in AWS or Azure, right?
No, AWS is not good for Kubernetes. You need to do a lot of configuration and it's very lazy in AWS. And in Azure, they are going to give you only 1 month of free. And that too, if you have one credit card, you can create a free account only for one time. After that, after 1 month, they are going to remove that free tier account and again it will be chargeable. So instead of that, for Kubernetes, Google Cloud is very best to practice GKE. So you'll get a lot of time that free tier account you can use it.
Yeah, I agree. But down the road, I may have to work on Kubernetes in Azure. So at
Yeah.
work, probably if I need to do it, and now if I practice in GCP, is that okay to continue to switch to Azure and work there?
Yes. See, 80 to 90% will be the same everywhere. Like what
Okay.
you are installing, managing, like not using any managed service, you are
Mhm.
installing by your own is also same. And they also same. Only thing is the support. And the thing is how you are accessing. If you are using, for example, AKS, you might be
Mhm.
using PowerShell to access the Azure cloud. Okay.
Okay.
And as I said, for example, in Azure, you have a concept called Azure File, okay,
Mhm.
which is like um, an NAS storage, so which we can create volume and which we can attach it to the worker nodes, and with that we can assign to the pods. So that other features what cloud is providing that may help you, but the cluster-wise concept is same. What are the commands you're executing? What are the resources you are using inside the Kubernetes cluster? Everything is same. How you are accessing it, how you are creating it. Like for example, in Azure we have networks, NSG rules, and in GKE also we have little NSG rules. The configuration of that infrastructure might be little bit different, but cluster point of view, everything is same. So 90% it will be the same.
Okay, thank you. So in GCP, normally whatever you're teaching, we should be able to use it, right? In free tier.
Yes,
Free tier. Okay,
yes,
thank you.
So do we get
Uh,
any all these recorded sessions?
yes. You will get recording sessions.
Okay.
at the end of the this course, do we get any sample project to hands-on on this?
Assignment kind of a thing.
Yeah, I will see. I'm not yet prepared. I'll let you know once we start the session. Okay. So because this is our second batch, so
Okay.
we did not have any kind of project for that. So if we have, then
Okay,
definitely we'll let you know about that.
Because
sure,
assignment will
definitely. Yeah.
help us a lot in like
Yes.
practical implementation.
Yeah.
Yeah, but the
Even
Node project or Java project in real life, if you take it and if you work on that, that should be more than enough. Yeah.
Yeah. See, if you are installing one application, 10 applications, everything is same. Only you need to configure that application dependency extra. Like some applications dependent on more things which are running outside of the cluster, maybe RabbitMQ, messaging queue, or maybe database, okay, or maybe to some other application, maybe .NET application is trying to connect, which is dependent on web UI. So apart from that, remaining configuring one application or 10 applications in the cluster, it will be the same.
Okay.
and one more
What?
thing. So yeah, every day you'll be taking class. Okay. So one request is like at the end of the day, so if you can give us some like assignment kind of thing on a daily basis. Okay. So we will
Okay.
try to implement that, and if we have any questions, we'll ask you in the next day class. So that can help us a lot.
Yeah,
So
sure,
is there
definitely
any
I'll give
like
you. To give assignments, I have lot of things we can ask you to do. So we'll see how many
that
people
is
will
a
do
where
that.
we can learn a lot.
Yeah, definitely I'll do.
Sure.
What is the course fees for this?
That you can check with Galaxy. Okay, later on you can ping them and ask.
So classes starts from tomorrow, right?
Yeah, tomorrow onwards. So tomorrow onwards we are going to start the Docker. So Monday to Friday it will be there.
Acha. Okay, and one more thing. So my agenda is, like I'm planning to, like change job. Okay, I have basic idea of, like all this stuff. So will this course help me in changing my job?
Yeah, definitely. Because see, uh, in real time they will ask you how you deploy the application. So that completely we are going to discuss, and what are the questions they are going to ask in the real time also, that is also we are going to discuss. And one thing I missed here, like live, we call as a liveness probe and readiness probe. That is also in a lot of interviews they'll ask you. So you can easily tell that you worked end to end to creating from the Docker file to deploying the application on the Kubernetes cluster. So easily you can crack the interview on the Kubernetes, because nowadays For every DevOps engineer, companies are expecting Kubernetes also. So with this course, you can able to clear like Kubernetes questions, whatever they ask you. Maximum 80% of the questions you can clear.
So what about ingress controller?
I have one doubt. Okay, so with this course, will we be able to clear that Kubernetes admin examination? Like,
See, this is not exam point of view, because in exam, no one will ask you about Helm charts or autoscaler. This they will not ask. This is to get the job, okay, on Kubernetes. And if suddenly, if you already are working the DevOps engineer and you don't know how to deploy the applications, for that it will help you for the real time scenarios, but not for the exam point of view.
oh, okay.
Yeah, I should
So
agree that practical experience is more important than exam.
so you will help us, like
Praveen, one question here.
yeah.
Yeah.
So for this, what is the prerequisites and how much coding knowledge is required for this? Do we
See,
need
coding
real?
knowledge is not required. If you know Ansible, if you might have written some Ansible playbooks, this because here we use YAML for deploying any applications, implementing anything, everything will write in the YAML file. So if you have basic knowledge about YAML, that is enough. In YAML also, it's nothing, only it's the syntax, and we need to take care about the space. And apart from this, if you are already DevOps engineer, then or at least you have completed DevOps course, okay, that's enough. If you don't know what is DevOps, what is Git, then you should start with DevOps and then you should come to the Kubernetes. That's it. That is the prerequisite. No need of any programming language. Okay. So you should know little bit of YAML. That's it.
I have knowledge on this Git and these tools, but not in-depth knowledge. That is fine to
Yeah,
continue for
basic knowledge like
Kubernetes.
Git, Jenkins or Maven and Artifactory. These four are mandatory. These four things we will uh, use inside this Kubernetes. One is to store the source code. One is to create an artifact Jenkins with Maven if it is a Java project. And another one is store the Docker image or artifact inside the Nexus or JFrog. These are the 3 to 4 things we use while discussing this course. So if you have idea about these three, then it's enough.
Can you repeat, please? Git, what is Git and?
Git, Jenkins, Maven, and Nexus or JFrog Artifactory.
So these are basic things to get into the Kubernetes, right?
Yes.
Okay. So one more last question. If you can you put directly Kubernetes on a container? I am working on these two areas from last 1 year. Can you show put a resume? Can we get in try outside the jobs?
See again, like 50 when you are putting resume in like Kubernetes in your resume. Again, whoever is calling you, if they have very good requirement on Kubernetes, they'll ask more questions on Kubernetes, and remaining questions they'll ask about Jenkins pipelines or Git or maybe some other topics. Okay. So how you are telling, see, by doing the course, I cannot tell you that you can clear the interview. How much interest you are showing, how much practical you are doing, apart from what you are learning from our side, and how much extra time you are putting efforts to learn the Kubernetes or anything. Based on that, you can easily crack the interview.
Mhm.
So will you help us in creating a resume at the end of the course?
I will share you the resumes, which includes Kubernetes. Okay. So that
Okay.
you can copy the lines whatever you are good, because you need to mention in your resume what you know. Okay. So that you can copy from that resumes and you can mention in your resume what knowledge you have. After that, once you prepare from your end, if you send us, then we can validate it. Okay, whether it looks good or if anything is extra. Because even if you don't know, if you're not confident about any topic, then instead of keeping that, you should remove that lines. Okay.
Okay.
Definitely.
And other things, so I mean, will there be at the end of the course, can you give us mock interviews kind of a thing?
Mock interviews, like I said, in the final session, I'm going to share you some questions, what kind of questions they will ask in the interview on Kubernetes. Okay, so that video, it will help you to like attend the Kubernetes interviews. Like, see, some companies if they literally need Kubernetes, then they'll only ask on questions on Kubernetes, or else they'll ask both, either your DevOps questions and 50% will be on the Kubernetes. So in the last session, I will share some questions with you so that you can prepare on that.
Fine, fine.
Yeah, sorry to disturb you guys. Shankar here. Just to give you an overview of this course. It will help you to improve your experience on Kubernetes and where you can get the real-time exposure. That's it. If you are looking just attending this course and getting a job, you are just blindly attending this course. And don't expect that once you attend the course, you will get a job. It never happens until you learn, and you should be the up to the market demand level. How many people has seen there is a jobs only for Kubernetes? Just let me know. You should at least have the skills which are required, and this is part of our DevOps tools. It's not like Kubernetes is alone a separate course. Of course, we can treat it as a course, but it doesn't help you much to get a job. If somebody have that opinion, please remove in your mind. And we don't take additional extra services. We can guide you in the right direction, that how can you prepare your resume, and also how can you attend the interviews. We can just guide you, but depending upon on us on this one may not help you. That's all I would like to say. If somebody have some questions regarding interviews or all this stuff. Moreover, we don't deal much as a typical institutes, okay, which you are going through unnecessary, what I can say, commitments we don't take. If you are really want to learn Kubernetes in good level, of course, this course will help you. Yep, that's all. Over to you, Praveen.
Thank you, Shankar. Yeah, Praveen, one quick question is, I know tomorrow when we start Docker, we are not jumping onto GCP. Probably we'll start on some Linux machines or something. Is that true?
Yes, exactly.
Okay, well, how about does Windows Bash will serve the purpose, or do we need to have a real Linux machine?
Sorry, what is Windows?
Windows Bash. Git Bash, which is a, the Linux component. Is that serve the purpose for Docker, or do we need to have a real Linux
No,
machine?
see, again, it depends how you create virtual machine. If you create in your local by installing VMware, or maybe you can create you can use for this purpose AWS account. AWS is giving you a free tier account for 1 year. For practicing of Docker, you can create AWS free tier account, and we can create one free T2.micro instance, and there we can do practice.
Okay, got you.
And one thing I want to add what Shankar has said, like, so we don't get job only specific to Kubernetes. Okay, so it's a DevOps engineer role. Already you might be working as a DevOps engineer, or you don't have job on DevOps. So when you're trying for a DevOps job, this is will be another tool will be help you, because for DevOps engineers nowadays, every company, most of the companies are expecting knowledge of Kubernetes. Okay, so in that way it will help you. It's not like only you are going to work on only Kubernetes stuff. No, okay. DevOps engineer itself need to work, like you need to work on Git, you need to work on Maven, and you need to work on Ansible and cloud. Okay, whether what are the cloud that project is using. Apart from that, also you need to work on the Kubernetes. Okay, so why people are showing interest? Because nowadays majority of the companies are migrating their applications from legacy applications to the microservices. Okay, so for that purpose they are doing Dockerization. So to run the Dockerization backend, it needs Kubernetes. So that's why they are looking for an experienced person, who the DevOps engineers who knows the Kubernetes. Okay, so DevOps engineer only will take care this thing also. It's an additional work, like how he is doing Ansible playbooks, and how he is doing Terraform scripts, and how we need to manage cloud. Same way you need to manage Kubernetes also, additional work. So that's why people are showing interest to learn Kubernetes, like DevOps engineers who are already working, or who are searching job on DevOps engineers.